Hi guys, welcome back to my channel. So today we'll start with pricing an option using the binomial model. Now I'm sure all of you know what an option is, right? It's basically a contract to buy an underlying asset on which the option is based at a particular time in the future for a particular price. That price is called the strike price, right? And we'll denote it by K. And the time period is called the exercising time or the maturity, right? So basically what an option is that an option is a function of several variables, and the binomial model to price an option was one of the first models that was invented to do so. And it's this binomial model is based on the idea of fair games, which I've made a video on earlier. So if you don't know what fair games are, just go through that video. It's not a very difficult concept, right? So the thing is, the entire idea of pricing an option is based on this idea of no arbitrage. Okay, so no arbitrage means that we cannot make an instantaneous profit from an investment that has no certain uncertainty. The pricing of a derivative is based on the principle of no arbitrage. And to price an option, we apply the no arbitrage argument and derive a PD that is satisfied by the option price. But in the binomial model, we won't be deriving any PD. We'll wait until we actually get there. There's a lot of ground to cover until we derive the PDE for pricing an option. But let's start with the principle of no arbitrage in general. Okay. So I want to explain what no arbitrage basically is. So let me first explain what arbitrage is and what does it mean if the market forms an arbitrage opportunity. So a market forms an arbitrage opportunity if there exists a self-financing strategy. Let's call that self-financing strategy theta. Okay, this is basically just a trading strategy. Such that I'm going to put some conditions here, such that these conditions are satisfied. That is, S naught theta is less than equal to 0. I'll explain what this is in a moment. P of S t theta greater than equal to 0 is equal to 1. And the third is P of st of theta equal to greater than 0 is equal to is greater than 0. Okay, this is greater than, this is not greater than equal to, this is greater than, this is greater than equal to, right? So theta here is a self-financing strategy. Self-financing basically means that you don't take money from anywhere else. The capital that you use is what you have with you. Basically it's net, it's no profit no loss. Okay, so I'm going to explain these conditions one by one. The first condition states that the value cost S, this S over here, the value cost S of the strategy theta at time 0, this is the time t equals 0, should be less than or equal to 0. Okay, should be less than or equal to 0. This basically essentially means that the strategy is not something that requires capital. Okay, this is self-financing. This you can, for example, you can take something like going short to obtain cash and then take a long position in another asset. So if we do that, we're not taking capital from anywhere else. It becomes self-financing, and the value cost of the strategy will remain less than or equal to 0, right? So this is the first condition for arbitrage. This is not no arbitrage, this is arbitrage. Uh, so basically this means that if it is less than 0, the trader actually makes money because you borrow cash and then you give it back or take a long position in some other asset, and if this is less than 0, then the trader actually makes money. So that's what the first condition is. it basically means, the first condition basically means self-financing, all right? You don't require any extra capital. And let's go to the second condition. The second condition states that the probability of the value of strategy S at time t, okay, the time here is t now, it's not zero, it's at some point of time t. The probability of the value of the strategy S at time t is greater than equal to zero, is greater than zero is equal to one. Okay, the probability that the value of some of the strategy at time t is greater than zero, the probability of that is equal to one. Okay, this basically means that the certainty that there is certainty that we will not lose any money. Okay, because this is the cost, the real value of the strategy, and if it's greater than zero and the probability of that is equal to one, so this basically means that we will not lose any money. Okay, right. And then the probability that the value of the strategy is greater than zero is greater than zero. Okay, so this basically means that there's a real chance that this will occur. Okay, there's a real chance that this condition, this one, will occur. The probability of getting a real value on your strategy is greater than zero, right? So there's a real chance that this will occur. That means you will make money, that you will definitely make some money. Now, the higher this value of probability, the better it is, because the more money you're making. So these basically form the conditions for arbitrage to exist. Now, to summarize, I'll just summarize this once again. The trader can set up the trade with no additional cost. That's the first point. The trade will definitely not lose any money. The second point. And there's a real chance of ending with a positive value. That means there's a real chance that you will definitely make money. You will make money, right? Right. So, what does it mean to be arbitrage free? Now, that might be a question that you ask. What does it actually mean in plain, simple English to be arbitrage free? So, arbitrage free means no arbitrage, okay? And no arbitrage markets are markets that exist in general equilibrium, where demand and supply are at equilibrium and variables exist in balance, all right? Which basically is the foundation for efficient market hypothesis. Okay, which basically means that all the information that you need, all the information surrounding an asset is already present in the price, and the the chance of making any real profit is zero, or it's random walking. Okay, so yeah, that's what no arbitrage means. It's in accordance with the efficient market hypothesis. To explain it in simple terms, let me just take an example. No arbitrage means that, if I short an asset, right? And let's say that asset stays constant, or if it even goes down a little, right? If I short an asset, I'll obviously get some money from it. Now, I can't invest that money to get a rate of return that's higher than the rate of return of that the rate in which I will lose money over here, right? So if I'm if I short an asset, if I lose money at 5%, minus 5%, if I long an asset and if I take this money from shorting the asset and I long it and I get a return of 8%, and if this definitely happens, then that creates an opportunity for arbitrage, because this is risk free profit. I can sell the asset, I can get money, and I can just buy or long another asset. So this should not exist. The idea behind this is that, once market participants find the arbitrage opportunity, once they realize that the arbitrage exists, they will go and the demand in this will increase. Okay, once the demand here increases, this will eventually come down. The rate will reduce from 8 to 7 to 6 or something else. It will come down until it's in equilibrium with this value, right? It will come down until these two values are in equilibrium. So you cannot make a risk free profit in the markets. That's basically the idea of no arbitrage. Okay, so now let's actually go on to pricing an option with the binomial model. So I'm sure you all know what a simple call or put option is. In case you don't, just Google search it. It's not very difficult, but I'm assuming that if you've come this far, you already know what an option is. So basically, an option is a contract that gives you the power, but not the obligation to buy an asset at a particular price K, okay, which is the strike price, at a particular time T, which is the maturity date. So if I buy an underlying asset at, now I'll just explain this with an example. Let's say I have an asset and at time zero, its value is $20. All right. Just change the pen here. 1 minute. Yeah. So I have an asset as not, and at time zero, its value is $20. And I know for sure that 6 months down the line, so our time period is 6 months. 6 months down the line, the asset is either going to be, ST is either going to be $27 or it's going to be $18. Okay, it's either going to be one of these values 6 months down the line. Let's just say somehow I know that through analysis or something, but it can't be any other value except for these two. Okay, and now I'm going to assume a lot of things here. I'm going to assume that the seller takes no commission and the risk-free rate of return is 12%. And the strike price of the option is $21. So basically, this means that I buy the contract at $20 today, and the underlying asset is, no, sorry, I don't buy the contract at $20. I'm sorry. The underlying asset, let's say it's just a stock. The price of stock today is $20. In 6 months, which is the time period, 6 months, in 6 months, it's either going to be $27 or $18. And my strike price is K, okay, which is $21. So this basically tells me that in 6 months, I'm going to buy the stock at $21, okay, even though the price of the stock is $27. So this is going to give me a profit, right? Because 27 minus 21 is equal to 6. So I'm going to get a profit of $6 on each stock that I buy. Because even if the price is $27 after 6 months, if I'm getting the stock at $21, I can just sell it back in the market at 27 and get a profit of $6. Similarly, if it goes down to 18, then I'm not going to buy the stock at all, right? Because why would I buy it at 21 when I can get from the market at $18, right? It doesn't make sense. I'm going to be buying it for a higher price, correct? So, yeah, so that's the idea behind a call option. Now let's go on to pricing this. Let me just draw the model here. The binomial model basically drawn like a tree. And in 6 months, it's going to be $27 or $18. And the entire point is to find this risk neutral measure of probability that we can use to price the option, right? And find the probability with which the option will be either this or that. So you'll understand this when I explain this right now. Just go through this video once more after I explain it, because the math even though it's not hard, it just takes some time getting used to. Okay, so now the buyer has a choice. So I'm going to look at this from the buyer's and the seller's perspective independently, and we are going to arrive at the same price of the call option. Okay, now how do you know that as a seller, let's say I'm a buyer and you're a seller, how do you know at what price do you sell this option to me such that in the long run, it's risk free? There is no profit, no loss for you, right? What price are you going to sell this option to me? You can sell it at, let's say, 100 or 200, but how do you know that 100 is the right price to sell this option, or 200 is the right price to sell this option, such that in the long run it's not profitable to you or to me, which is the buyer or the seller? So first I'm going to look at this from the buyer's perspective, right? The buyer. And now the buyer has a choice. Okay, he can buy shares or he can buy a call option. And I'm going to assume the market price is fair for the shares. Okay, that means that it follows efficient market hypothesis. There's all the information is there. There's if you think that if you make an investment, it's as good as making an investment in a random walking time series. All right, efficient market hypothesis exists. Arbitrage opportunities do not exist. So let's say from the buyer's perspective, I'm going to write the equation here. The price, the the present price of the option from the future is 27 e to the power minus RT, which is 0.12 into, I think this is too light, I'm sorry about this. Yeah, 27 into e to the power minus 0.12 into 0.05. Sorry, 5. So when you get this, you get 27 e to the power minus 0.06. What I'm doing is I'm discounting the value, the future value to the present, okay? Because I want to find the risk, this value of P, okay? So I'm discounting the future value to the present. Similarly, for the loss making, for this second trade where it goes down, the price of the asset goes down, the present value discounted as 0.12 into 0.05, which is 18 into e to the power minus 0.06. Okay. So for a fair game to exist, when I take the when I multiply the probabilities to these values, it should be equal to 0, right? Oh, sorry, I'm sorry, not 0. It should be equal to 20 because 20 is the price of the asset. 27 e to the power minus 0.06 into P plus 18 into e to the power minus 0.06 into 1 minus P is equal to, what will this be equal to? For a fair game, this should be equal to 20, right? Because I'm discounting both the values, taking their probability measures to the present price. So for this to be fair, it has to be equal to 20 at all times. Okay. Now, well, if we solve this, we get the value of P. I'll just leave the solving to you. It's not a very hard equation to solve. You just have to solve for P. It's an equation in one variable. You get the value of P as 0.3596. Okay. So this is the risk-free probability measure, okay, where there is no risk. In the long run, if you keep doing this at the same price, at the same underlying price of the asset and the same strike price, in the long run, you will not make any profit or any loss. So this is called the risk-free probability or risk-neutral probability, right? Now, what I'm going to do is I'm going to find, this is not the price of the option. This is the risk neutral probability, but I need to find the price of the option, right? So the share price rises. If the share price rises, the buyer will make $6, which I'll have to discount again to the present value, which is minus 0.06 multiplied by the probability, right? And if he loses, if he doesn't make any money, if the price goes down, then he's not going to make any money. It's going to be 0. 0 into e to the power minus 0.06 into 1 minus p, right? This is again just simple expectation, which you know from your probability distributions. I'm just multiplying, I'm discounting the future value of my profit to the present value and multiplying it with the probability measure, risk neutral probability measure. If it goes up, I make $6. If it goes down, I don't make anything. So this is naturally 0. And when you do this, when you multiply this, the value of P from here, you get the value of the option as 2.032. So in a risk neutral measure, when no arbitrage exists, when arbitrage does not exist, or under the no arbitrage uh, assumption, the the price of my option at which I sell my call option according to the binomial model should be 2.032, right? Now, this is from a buyer's perspective. I want to also look at this from the seller's perspective, right? This is basically this is basically the total expected return. Expected return, all right? And now I want to look at this from a seller's point of view. Look, I'm solving this from the buyer's point of view. I'm trying to find the risk-free, risk-neutral probability measure and then arrive at the value of the option from a buyer's point of view and the seller's point of view independently to show you that this method is this assumption and the assumptions that we make and this method is intact. It's perfect. Okay, so from the seller's point of view, I'm again going to make assumptions that there are no commissions, there are no profits, no risk, no losses. Okay, in this entire model, there are no commissions, no profits, no taxes, no risks, no losses. So if I do this as a buyer and a seller, if a buyer and a seller do this for a very extended period of time, buying and selling the option at this price, in the end, after a lot of iterations, they will end up with where they started. They will not make any profit, they will not make any losses. So let's do this from the seller's point of view. From the seller's point of view, let's assume that the call price is just one share. Okay, so now let's say I want to buy delta shares, okay, right? And let's just say that there's just one contract. Okay, this contract is for a particular number of shares, which is delta shares. Okay, so the call option uh, exists for some number of shares called delta. Okay, and as a seller, I don't want. I'm gonna borrow some money. Okay, so how much money will I have to borrow if I want to sell this option? Is basically 20 delta minus G. Okay, so 20 delta is the price of all the shares currently, and G is the money I will get if I sell the contract to the buyer, right? So I'm going to borrow this much money, and what happens is if I take 27 delta, if the price goes up, then the money that I have to give back is 20 delta minus G e to the power 0.06 minus 6. All right. So look, I'm going to borrow money, right? Because let's just say I don't have money. I need to borrow money. How much money will I have to borrow for these shares? I'll have to borrow uh, 20 into delta shares minus G because I'm going to get the money which is equal to the value of the contract, which is G, from the buyer. So I'll have to borrow this much money and I'll put it in an investment which gives me the risk-free rate of return of 12% for a period of 6 months. So this for the future value of 6 months at risk-free rate of return 12, I'm going to multiply this. I'm going to put this in an investment, right? So in the end, if the price goes up, I'll have to give him back $6 and I'll have to give this value back too, right? Um, and then again, if it goes down, then I won't have to give back any $6. I'll only have to give back this value, which I'm going to put in some risk-free asset. Okay. Now for a no risk, no loss situation, these both should be equal to 0. Okay. There's no risk, no loss. Uh, So obviously I will have to go, yeah, there's no risk, no loss here. Okay. So when I solve this, I'll get the value of delta as 2 by 3. And when I solve this, I'll get the value of G as 2.032. This is the value of the call option, which is exactly equal to what we got from the buyer's perspective. We arrived the same value from the seller's perspective as well. So we can say that uh, we can say that G buyer is equal to G seller. and hence the buyer and the seller agree on a price that is fair. Okay, both acted independently and both arrived at the same price of the contract. I hope you understood all of this. I'll stop this video here. Just go through this video once and go through the entire thing once again. If you have some doubts, just put it in the comments below and I'll try my best to answer them. But yeah, I'll stop the video here. Thanks for watching.